lesson, you will solve linear inequalities by using addition and solve linear inequalities by using subtraction. So, what are inequalities? They are an open sentence that contains a less than symbol, greater than, less than or equal to, or greater than or equal to. What is set builder notation? It's a concise way of writing a solution set. For example, in fat man brackets, t such that t is less than 17 represents the set of all numbers t such that t is less than 17. So we will write our answers like this. Maybe in the past you have solved and written like this. This is not enough today. What you will do today is you'll put a fat man bracket, t, a little line that means such that, or when, t is less than 17. So this is how we'll write all of our answers today in set builder notation. The addition property of inequalities states that if any number is added to each side of the inequality, the resulting inequality is also true. Subtraction property of inequality states that if any number is subtracted from each side of a true inequality, the resulting inequality is also true. So let's try it. This is going to be solved by adding. So we pretend that this is just like an equal sign, and we're going to use inverse operations. So what's the inverse or opposite of subtracting 12? Adding 12, right? So we add 12 to both sides. So our result is x when it's greater than or equal to 8 plus 12, which is 20. We're almost done. Remember what we have to do? Fat man bracket, x such that, fat man bracket. Now we're done. We can check our solution. 20 minus 12 is 8, and so that would be 8. And then you could try things bigger than 20, greater than 20, 21, so on and so forth, and that would be things greater than 8. Moving on. We want to use addition here as well, and then we're going to graph it. So opposite or inverse of subtracting 8 is adding 8. We add 8 to both sides. This becomes 30 is greater than m. Well, we aren't ready to answer this yet. We have to put it in set builder notation. So it's m such that m is, look what the alligator's eating. The alligator's eating the 30. So we flip this symbol. M is less than 30. And we just want to make sure, is m less than 30 over here? Yep, and it's the same over here. So the way we graph this is we find 30, and if it's less than 30, that means there's going to be an open circle on it, and it's going to be everything less than that. I had a student once tell me, Mrs. A, if this is pointing like an arrow, it points the direction that you shade it. And that's right. It's everything less than 30, so it goes in this direction. That's always the true when this variable is first. So this is the graph, this is the solution. Try the examples in your notes. Now, how do we solve by subtraction? Well, in this case, you'll notice this is adding 19, so we subtract 19 from both sides. And we get m is greater than, this would be 37. And you can check my math there if you would. So we are almost done. We have to put it in set builder notation, fat man bracket, m such that m is greater than 37. Graphing, we find 37. It is not equal to, so we can't put a solid circle. We have to put an open circle because it's not equal to, open circle, and it's everything greater than 37, so this direction. And if you look, that's the way the arrow is pointing as well. Try the subtraction example in your notes. Now, for example 3, what happens when we have a variable on both sides? Where our goal is to get variable on one side and number on the other. So what we're going to do here is we're going to subtract 3a first. Think about why we're subtracting 3a first. I want to get this 6 by itself. I want all my a's together on the right side. If I subtracted 4a over here, I wouldn't have that. So I have 6 is less than or equal to a, or 1a. This is not my final solution. Remember, we need set builder notation, a such that a is, see how the alligator is eating the a, so it must be the same over here. So my solution is a when a is greater than or equal to 6. So here is 6 on the number line. This one is equal to, so it's a solid, and it's everything greater than 6. And that is our graph for this situation. All right, next up. these are the symbols that we have, and when you are using real-world problems, you might see this as less than, or you might see this also as fewer than. And I put these in your notes, and you can just look in your notes to read these if you'd like. This you're going to see as greater than, or you can also see as more than. This you're going to see as at most, no more than, or less than or equal to. And finally, you're going to see here, this is at least, no less than, and greater than or equal to. Now, I would really highlight this section in your notes, because when we do writing of inequalities from real-world situations, you want to have these in your notes. So let's try an example here. Gage needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. Currently, the basking spot is 62 degrees Fahrenheit. So how much warmer does the basking spot need to be? Well, first of all, we need to come up with a variable. So let's say let T represent the temperature. And now that we have a variable, we can write an inequality. So a good-looking inequality might be 62.5 plus T has to be at least. Look at your notes. What is at least? Look at it. The symbol that we're going to use is this symbol, greater than or equal to, and then 82. So look at this equation and see where I got it. See how this inequality makes sense. Look at the problem, see where the numbers came from, see how we put it together, because that's what you'll have to do in your real-world situation. Sorry, I can't talk. So I want to solve for this now. So I'm going to subtract 62.5. And we get T is greater than or equal to. When we subtract that, we get 19.5. I think we're ready to answer the question now. How much warmer does the basking spot need to be? The basking spot, let's think about what this means. Greater than or equal to 19.5 degrees. So we could say the basking spot needs to rise 19.5 degrees or more. So it could rise exactly 19.5 degrees or anything greater, so I put or more. Now, could you say this in a different way? Absolutely. You could say something else as long as you are making it true that it could be 19.5 degrees or greater. You'd be fine. Try that last example in your notes, and then you're ready to go for tomorrow.